Hello guys, welcome to my channel. This is Ehsan, and in today's video we're going to talk about another electronic quiz, which is about this integrator. We have this integrator and we're going to design this, determine the values for R1 and R2 in order to satisfy the assumptions for this circuit. But before we get started, if you're new here, please give me a thumbs up, hit that subscribe button, and also the notification bell, so whenever I upload a new video, you'll be aware, right? Let's jump into it. So this comes from Fundamentals of Microelectronic Behzad Razavi's book. I think it's chapter 8.50 is the number of this problem. So here it says that the integrator of figure shown below must operate with frequencies as low as 1 kilohertz. So first of all, what does that mean? Operate frequencies as low as 1 kilohertz. This means that the first pole, which is created by this capacitor and this resistor, must placed much lower than 1 kilohertz. So here 1 divided by R2C1, which is pole created by this resistor and capacitor in this circuit, must be less than the frequencies, the omega of this 1 kilohertz. Omega, this is in F. In order to recalculate it as omega, which means radian per second, you had to place 2 pi before that. 2 pi times 1 kilohertz, which is 1000 hertz. Okay, and at the end it says that C1 must be less than or equal to 100 picofarad. By choosing C1, the exact number 100 picofarad, okay, you can calculate R2. You cannot calculate, you can actually determine the minimum value or maximum value, which is in here R2 by really simple calculations must be much higher than 1 divided by 2 pi times 1000 times C1, which is 100 picofarad. Okay, so this is the minimum value for R2, and by using my calculator I can draw that and calculate it 1.59 mega ohm for R2. Now, while providing an output offset of less than 20 millivolt, output offset less than 20 millivolt with OpAmp offset of 3 millivolt, determine required values for R1 and R2. Okay, now how about this output offset and this input offset? Here we can calculate this by calculating the DC offset values for V out versus V offset in the input. Okay, in the DC, this C1 is open circuit and this is an OpAmp, ideal OpAmp, so the current through this is 0. And if this node is equal to VOS, this node is exactly VOS. And by simple KCL, you can calculate it. KCL in here, this is the current and this current. By using KCL, the addition of this current and this current are equal to 0. So KCL at V minus of the OpAmp, this is VOS divided by R1 plus this is VOS minus V out divided by R2. Equal to 0. By simple math, you can calculate V out equals to 1 plus R2 divided by R1 times VOS. Now VOS equals to 3 millivolt and V out equals to 20 millivolt. So again, using simple math, R2 divided by R1 equals to 20 divided by 3 minus 1, which is 17 divided by 3. So this is the ratio between R2 and R1. In most electronic designs, you end up with some ratio between resistors, and by some limitations you can calculate both resistors. And just for the sake of simplicity, I can choose R2 value. I can choose R2, which means that you can choose it something else. 17 mega ohm, just for the sake of simplicity. And here, so R1 equals to 3 divided by 17 times 17 mega ohm, which is equal to 3 mega ohm. Just for the sake of simplicity, you can choose something else, but be careful. R2 must be greater, much greater than 1.59 mega ohm for the consideration of this 1 kilohertz frequency. Okay, so not anything near this value, because much greater, maybe 10 times this value. Okay, maybe 15 mega ohm. Okay, that's the answer for this question. And here we look at some OpAmp non-idealities such as offset, and determine the values for R1 and R2 for this integrator. I hope you like this video. If that's the case, please give me a thumbs up and share this video with your friend. Thanks for watching.